So, we've got this intriguing study on antibody blockade of activin type 2 receptors combined with GLP-1 receptor agonism, which really preserves muscle mass while enhancing fat loss in obese mice.
Yep, right. And this is accomplished using bimagrumab, a monoclonal antibody that blocks ActRI signaling, thereby removing the inhibitory effect on muscle growth,
Mm-hmm,
correct?
exactly. Normally, activin A and myostatin, which are part of the TGF-V family, act as brakes on muscle growth. By blocking their receptor, you effectively release that brake and it's like, well, promote muscle
Yeah, definitely.
hypertrophy.
And then, when you add GLP-1 receptor agonism through semaglutide into the mix, you get significant fat loss. But typically, that comes with muscle loss. So the combination helps maintain lean mass, right?
Precisely. Right. And the study showed that in diet-induced obese mice, bimagrumab alone increased lean mass by about 10% while reducing fat, whereas semaglutide caused robust weight loss, but at the cost of both muscle and fat mass. The combo, though, really struck a balance by enhancing fat loss and preserving muscle
That's
mass.
crucial. It's fascinating to see that metabolic markers also improved, like lowered blood glucose and improved insulin levels, along with reduced inflammatory markers such as IL-6 and MCP1. It really suggests an all-around metabolic
Yeah,
enhancement, right?
exactly. And something particularly cool was that the improved exercise performance was tied to increased muscle mass. They even did a VO2 max test, which showed significant enhancements
Right,
in
that's a great link
endurance.
between the molecular changes and functional outcomes. One thing I'm wondering though, how do we know this muscle hypertrophy is completely due to ActRI blockade? Did they look into other pathways?
Well, they did actually. They explored the ACT pathway, which is typically known for muscle growth signaling. Interestingly, even in mice lacking both ACT isoforms, muscle hypertrophy was only modestly reduced. This implies there are ACT-independent pathways at play here that support muscle growth.
That's a fascinating twist. So, if we think about it, it's like there's a backup system ensuring muscle preservation even when the main route is compromised. That adds robustness to the strategy. Would you agree?
Absolutely, yeah. And from a translational perspective, this could be a game changer for individuals undergoing weight loss therapy. Usually they risk losing precious lean mass, but here, combining these therapies might help keep that muscle intact while cutting fat.
Indeed, that could really shift treatment paradigms. While the findings are promising, do you think the sample sizes in mice, like 8 or 9, might limit the broader
That's a
applicability?
valid critique. Sure, the mouse model sizes are relatively small, and translating these results to humans always has its challenges. But the consistency of the metabolic and physiological improvements across multiple measures gives it a lot of weight.
I see your point. So, overall, this study really bridges the gap between fat loss and muscle preservation, using a smart combination therapy that tackles both ends of the spectrum.
Exactly, it's a sophisticated approach addressing body composition holistically, and it opens the door to future therapies that could combine um, different mechanisms where you can, lose fat without sacrificing muscle, which is critical for long-term metabolic health and physical function.
Right on, it's certainly an exciting prospect.